Welcome back. Today, looking at covalent bonding. This is still part of Unit 3. So what we're going to do, we're going to look at how and why covalent bonds form. We're going to look at a couple special cases, which we call diatomic elements. Begin kind of thinking, what that word diatomic means. And then also we're going to talk about how many bonds can form. We'll also talk about drawing these as well. So just a quick review, how many valence electrons do each of the following have? I'm not going to go through all of them, but again, valence electron is going to be very, very important in terms of determining how things bond, a lot like last chapter. Here, though, those valence electrons aren't going to transfer. We're not going to add any extra. It's going to be, there are no electron transfers. There's no ions. Here we're just going to share. So what are molecular compounds? They are non-metal combinations. They form something we call covalent bonds, which is a bond between two atoms due to their attraction to a shared electron. So ionic bond was a transferred electron, but since there is no transfer, then there are no such things as ions, and then which means we don't have ionic bonds. We have covalent bonds, which we share. So we share. Follow completely different naming rules. I think an easier set with those prefixes. Let's say these are truly made of molecules, not formula units. So an ionic compound is made of a whole bunch of formula units stacked on top of each other. We'll look more into this, but these are truly made of molecules. So a molecule is a separate, distinct particle held together by covalent bonds. So H2O can be by itself. It doesn't have to be attached to anything else. It is a distinct particle. I can have one H2O. Alright, so covalent bonds, remember nonmetals attempt to gain electrons to fill that outer layer. Again, octet rule still applies, but the problem in this case is, well, if they're both trying to gain electrons to fill their outer layer, where do these electrons come from? So transfer isn't going to work. So how can two nonmetals bond together? Well, they can share. Example. If we look at, let's look at bromine and bromine. If I draw valence electrons, so 1, 2, 3, 4, 5, 6, 7, and I draw valence electrons here, 1, 2, 3, 4, 5, 6, 7. Well, wouldn't it be really easy if just this electron and this electron, well, or this bromine shares this electron with this one, and this bromine shares this one with this one? That's exactly what happens. They actually share a couple of electrons. It makes this really nice. So, as you see here, we would call this a bond. So we would say bromine is forms one bond. Well, how do we know this, and kind of what's the trend? This is determined by valence electrons. So as we saw, not yet, but hydrogen, it has one electron. It needs an extra one, so it's going to form one bond. The halogens, like we just saw, have 7. They need one more, so they're going to form one bond. 6, they have 6, so they need 2, so they're going to form 2 bonds. So things like oxygen, column 16. And this trend continues. For our nonmetals. Again, we're only talking about nonmetals here. We do have one nonmetal that is in group 3A, so in that column 13, right above aluminum, and that's boron. Boron's weird. Boron is small, so it actually doesn't get a full octet. So it has 3, which means it would need 5, but it doesn't get 5. It just shares, it just forms 3 bonds. So that's kind of a weird one. The other thing then is, so these extra electrons that are not in the bonds, they're shown as lone pairs. So let me go back here. These, something like this, or this, or this, or these, or these, or these, those are what we call lone pairs. And my smartboard's gonna not like this. Lone pairs. So that's what that means there. In terms of predicting number of bonds, so the same thing, but you can see here, so if we draw Lewis structures for all of these things, we said this column wants 3 bonds. Well, if you look, there's 2 that are paired up, so those aren't going to bond. But then, hey, 3 singles going to form 3 bonds. Here, not going to bond, but we got 2 singles. Those are going to bond. This is where drawing your Lewis structures correctly and not pairing them up, so not drawing carbon like this. It does, if I draw it like this, it doesn't look like carbon's going to do anything because they're both paired up. But if I draw it correctly and draw my Lewis structure like this, carbon is going to form 4 bonds. So be careful there as how you draw it. It'll help you a bunch. All right, these diatomics, these 7 elements, when by themselves, always pair up to form 2 atom molecules. So these are all elements, but they form molecules. These are our SQ2s, if you remember back from that first POGIL we did. So you're going to be expected to know how to name them. It's really easy. You just call that hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. That's their elemental form. You just name it like the element. So don't use dihydrogen. Don't try to change the ending to "ide" or anything like that. So these are easy to find on our periodic table. There are 7 of them. They form a 7, except for hydrogen. He's by himself. Or you can kind of think of it as, I like to use the mnemonic HON. Maybe. HON F Brickle. So hydrogen, oxygen, nitrogen, fluorine, bromine, iodine, and chlorine. So I think Professor Hahn F. Brickle. It sounds, he sounds like a German chemist. Hahn F. Brickle. All right, so what do these molecules look like? So if things form bonds, well, how does it look when they do that? So we're going to talk about a few of these things. We're not going to get to the 3D structures by any means. All right, so Lewis structures. We've drawn Lewis dots before. So you'll still hear me call them Lewis structures. You'll hear me call them dot structures, electron dot structures, Lewis dot structures. All of those things, I'm really talking about the same thing. Where remember, each dot represents our valence electron. So this here are valence electrons. So let's draw electron dots for the first 8 elements here. So hydrogen, hydrogen has its 1 valence electron. Next up is helium with its 2 valence electrons. The third element, lithium, with its 1. This is where my smart board is going to really not like this. Lithium with its 1, 2, 3 valence electrons. Up next is beryllium. So beryllium with its 1, 2, 3, 4 valence electrons. Boron is next. 1, 2, 3, 4, 5. Again, notice the order as I circle around. After boron, we have carbon. 1, 2, 3, 4. And the last one, let's do nitrogen. 1, 2, 3, 4, 5. So again, just making sure you draw them correctly. These can also be used to show how atoms bond. So if we look at Cl2, so one of those diatomics, we have chlorine with its 7, and then we have another chlorine. I'm going to draw it 7 a little different. So there's 1. So there's 1, 2, 3, 4, 5, 6, and 7. Notice if I squeeze those together just a little bit more, they could share those 2 and they would both think they have 8. Let's do the same thing for water. So water, hydrogen, with its 1. We have oxygen in the middle here, and I have another hydrogen with its 1. Oxygen with its 6. Looks like that. Kind of clustered, but you can see how if hydrogen shares this, oxygen and hydrogen share this over here, everyone has 8, hydrogen has 2, everyone's happy. The last one, CO2. So if I put carbon here, carbon with its 4, and then I got an oxygen with 6, an oxygen with 6. Well, you can see it's definitely going to form one bond, definitely going to form a second bond, and then they both still have this one pair left over. These two are connected here. Well, that's really, really confusing. If I would have maybe thought about it a little bit better, I could have at least got them closer together and get something that looks like this. With my carbon. And then I still have those extras over here. So again, maybe not the best way to do that. So we can clean this up by using lines to show bonds. So this is what we call line bond structure. I will probably also still call it a Lewis structure. So if I ask you to draw the Lewis structure for these things, what I really mean is I want you to draw lines as bonds. It just makes it much, much cleaner to see. So to clean those other ones up, if I had chlorine and chlorine, we said they were sharing 2. So I'm going to draw one bond to show they are sharing 2. And then those other non-bonding ones go around. Same thing with O2. Again, oh my gosh. So there, my oxygen sharing one over here, sharing one over here. It's got 2 bonds, everyone's happy again. And then that last one, we had carbon in the middle. It was sharing 2 with this oxygen and 2 more with this oxygen. And then we had 2 pairs on each that weren't sharing, but were just out there by himself. So this would be the line bond structure. Like I said, I'm going to still call this the Lewis structure as well. So how do I do this so fast? Well, it's because I've seen these a million times, and it's because I know what I'm doing. And then, you can too if you practice. So I'll have a handout for you which will help you do this. Just a set of guidelines. So use this kind of as you become used to it, and then eventually you won't need it.